Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2008 Calculus BC exam question number 1 from the graphing calculator portion. This question made a cameo appearance on the Calculus AB exam as well, question number 1. The problem reads, let R be the region bounded by the graphs of y equals sine pi x and y equals x cubed minus 4x as shown in the figure above. And it says find the area of R. Well, if you're a BC student, this question is going to be pretty straightforward, but if you're an AB student, a lot of this question revolves around the mechanics of the calculator. And so before we get started, I'm going to just do a quick little tutorial of the calculator here real quick. So if you want, you can fast forward through this portion of the problem if you want to. I've already put in the functions. F1 is the sine of pi x, and F2 is the x cubed minus 4x problem here. But unfortunately, my problem doesn't look like the one that they gave to us in the picture. So what I'm going to do is I'm going to go ahead and go to Menu. I'll go to Windows Zoom, and I'll go to Windows Settings. Now, the reason why I'm going to Windows Settings instead of Zoom In this time is because we actually have pretty good parameters based on the picture that we were given. I'm going to make my x min 0 and my x max 2, just like the picture showed me. And I'm actually going to scale them by 1 because it looks like the graph is letting me do that based on the picture. Again, I'm basing everything off the picture that I'm seeing. My y min will be -3, and my y max will be 1. Again, I'm basing these all off of the picture, and I'll go ahead and just scale the y's by 1, again, because the picture looks like it's scaled neatly to 1. I'll hit OK, and it looks like I've got the graph that they want me to find. Or it looks like my picture looks like the image that I'm supposed to be seeing. Now, if you want to, sometimes it helps if you give yourself a little bit of leeway on the graph. So actually, on my y, I'll make him -3.5, and I'll make my y max 1.5, just so I get a little bit of extra here. It's up to you on how you decide to label it. Now, if these function deals are getting in your way, just click one of them. And when it highlights blue, just hit the delete button. As long as you can tell which one's which, we know that the blue is the sine and the red is the polynomial. Again, I'll go here. When my cursor turns into Master Hand from Super Smash Bros., I'll click on him. And just like Master Hand from Super Smash Bros., if you don't want to delete him and just want to get him out of the way, you click and hold until Master Hand grabs the thing. And I don't know if it grabbed it. There you go. It grabbed now. Master Hand, and you can take him and you can move him, or like Master Hand, you can throw him off the screen or just delete him. Alright, cool. Let's go ahead and take a look back at the problem here. Oops, we don't need to see Final Fantasy 13. Okay, so from here, finding the area of R. Well, that's just a matter of top versus bottom, so we can do that. So in the calculator, what I'm going to do is I'm going to go ahead and go top minus bottom. So that looks like it's going to be sine minus polynomial. So when I hit the calculator button that's running away from somebody, I will go and hit my integral button, which is going to be shift plus, that's the shortcut for an integral. My limits of integration will be from 0 to 2 because that's where the two graphs intersect each other. And again, if I wanted to, I will go back and I will go and reference which one is which. So if I hit the tab button, F1 is my sine, F2 is my polynomial. So instead of having to type those in, I'll just say F1 of x minus F2 of x dx, and sometimes you end up with an exact answer. Just for safekeeping, if I ever want a decimal, I'll hit Control Enter. Now, for those of you who have the TI Inspire CX without the CAS, there is no exact value option, so you'll just get a decimal no matter what. But in this case, the answer straight up is 4. So how do I show work for that? Well, in part A, I'm going to say the integral of 0 to 2. Now, in my work, I'm not going to call it F1 minus F2 because the problem doesn't understand that. I'm actually going to write out what they are. Sine of pi x minus, and in parentheses, x cubed minus 4x. Again, the readers during the AP, they don't know what F1 and F2 are. I have to be very clear with what I'm putting into the integral. And I believe that will scoop up all of our points for that problem here. In part B, it says the horizontal line y equals -2 splits the region R into two parts. Write but do not evaluate an integral expression for the area of the part of R that is below this horizontal line. So let's take a look at this y equals -2. That's gonna do this right here. and I want to find the area of R that is below the horizontal line. Well, it's almost exactly like A, except in this case, top minus bottom is going to be line minus curve. So if I'm going to go with my gut, the sine function has no purpose in part B. What I need to do is I need to find out where this function intersects. I can do that in a couple of different ways. I can use the solver function of the calculator, but I actually don't like that. I'm going to go and hit the calculator button running away from somebody again, and I'm going to go to tab, and I'm going to hit F3, and I'm going to type in -2, and there's my black function right there. Now here's the shtick with putting in a third function. If I go to menu and go to analyze graph for intersection, it's going to ask me which graphs are intersecting, because right now there are 3 intersections at play. I'm going to hit graph of F2, second graph is graph of F3. That way the calculator knows that I'm looking for the graphs of the points of intersection of those 2 functions. Lower bound, upper bound, here we are, and then I'm going to do it again. Analyze graph, intersection, again I got to select the graphs that I want to intersect each other, lower bound, upper bound, and you see how that's kind of messed up? Master hand will grab this character and move him up the screen. I can go and get rid of the black f of x equals -2. Those are my points of intersection, which are my limits of integration for finding the area. So let's go and put that in. Calculator button running away from somebody. Shift plus. My limits of integration were 0.5391, and the upper limit was 1.6751. Again, I got that from finding the points of intersection. Now remember, finding area is just top minus bottom, so I think it's just going to be line minus curve here. So I think it's going to be -2 minus, and in this case, f2 of x dx. And again, I'll hit Control-Enter and get an answer. And that's what I'm going to write in. So that's going to be the integral from the integral from 0.5391 to 1.6751 of -2 minus x cubed minus 4x dx. And actually, I was mistaken. It says do not write but do not evaluate. So actually, part B is done. Since we wrote the integral, we're all set. All right, part C. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. So this sounds like a cross-sectional volume. Calculus AB students, this particular year in 2020, you will not have to worry about that, but in BC we will have to. From here, this is going to be the integral from 0 to 2, since it's the entire region of R. And in this case, it's going to be top minus bottom again, so sine of pi x minus x cubed minus 4x. And that all is going to be squared. And that's because, remember, it's a square, right? And the distance of the square is the sine minus the poly, which means the height will have to be the same thing. And once I evaluate that in the calculator, that's going to be 9.978. Let's take a look at part D. The region R models the surface area of the surface of a small pond. At all points R, the distance x from the y-axis. The depth of the water is given by h of x is equal to that. Find the volume of the water in the pond. Okay, if we're going to find the volume now based on a different type of cross-section, now we're looking at this thing as a small pond, it's important to note that this is just a really clever way for them to ask you about a rectangle, where, again, the base is still the sine minus the polynomial, but now the height is 3 minus x. So it's almost identical to C, except instead of squaring my base, sine of pi x minus x cubed minus 4x, instead of squaring the base, he's just going to get multiplied by 3 minus x dx. And that will ultimately lead me to an answer. Let's find out what that is. So that's going to be shift plus 0 to 2, and then f1 of x minus f2 of x. And that's all going to get multiplied by 3 minus x dx. and Control Enter. 8.3699. So 8.3699. And I believe that will wrap it up for this problem. Again, pretty straightforward FRQ. It's just basic volumes. I think the hardest part is getting used to the calculator. As always, please leave questions and comments in the comments area, and I will see you in the next episode.